Today, let's talk about gait events and real-time detection of it. First of all, we would like to just let you know that this is not a replacement. These kind of tutorials are for Motek training. And please just have a look at this disclaimer and use them with your own responsibility. We're happy to discuss things. And if you need any special training, please contact us. So the idea here is to find, for instance, mid stance, all right? The similar thing can happen for other gait events, but you can see that we find that and then we show it as the person walks mid stance, all right? If you look at the literature or just simply Google gait data using, for instance, AI or machine learning, you see that there's a huge number of things happening around. Different methodologies, but overall the methodologies come to this kind of procedures. So there would be a sensor or even video cameras or something from in the lab, and you collect data from a person, and then that data will be fed into a machine learning model, and then you'll have a prediction of say gait variable, for instance. So have a look at this paper. It's actually nicely compares different types of machine learning methodologies as well. But how about real time? For instance, in Motek devices with dflow, we want to go real time gait event detection while the subject is is doing an experiment for different reasons. I would like you to tell us what you would do with this information. So for instance, if you look at, for instance, a CTG file here, you see that the ground reaction force and ankles provide quite a lot of information here. And at mid-stance, for instance, right mid-stance here, you see that the markers are passing, ankle markers, quite close. There's a relationship here. There's a relationship between GRF and left and right. One of them is, there's a force, the other one is just the threshold. So basically, you can define a simple equation here to identify mid-stance, all right? And pretty much the same for other gait events, So here's what I just described in as a code. So you get all the information from the markers and from force plate, left and right, and then you say just if and then. If, for instance, the differences would be greater than or smaller than distance or threshold, and the force would be somehow the same, then the broadcast, for instance, mid-stance left or mid-stance right. Okay, it's very, very simple. You just have like 4 data points given at any given time, during your experiment. So you see how quick we can do that. So what can you do with this type of applications? And can you even model, for instance, say like use or implement an AI machine learning model in dflow? So let's do it quickly with dflow, show you how we do this. So this is what I created quickly for you. And this is the person who is walking, okay? So if you look at it, if you start the application, you see that it reads all these input and output, just 2 markers and 2 force plates. And then these are just simply initialization, and then gets these values. After that, that would be what I showed you, if and then. If this is less than that threshold, and then the force plates are, and the forces are, one side is greater than the threshold, you can actually define these thresholds here, right, yourself, or you can have another input. And as you can see here, it's nicely when the right foot just passes by the left foot and mid-stance happens, right? As simple as that. So let us know what you would do with this, and hope you enjoy this simple application.